Combinations, this is section 8.6. Combinations are a collection of objects in which the order does not matter. Keep that in mind. Order does not matter. Now, permutations are different. Permutations, the order does matter. So, let me try to help you understand this. In permutations, we're looking for arrangements. You can rearrange something and call it something new. Whereas in combinations, if it's the same group of letters or objects or numbers or whatever, you can't rearrange it and call it a new combination. So let's take the letters A, B, C. In combinations, that's one group of 3 letters, A, B, C. Well, with permutations, there are 6 arrangements of that. So as you can see, permutations are always bigger than combinations. Unless, of course, you're talking about a group of 1 object. Then, of course, there would be 1 combination and 1 permutation. So that's the difference with permutations and combinations. You can rearrange them here and call it new, whereas the combination says, nope, that's not something new. Lockers. Lockers are opened with an arrangement of 3 numbers. Now, does the order matter? In other words, can you open the locker? Could I rearrange these numbers and open the same locker? The answer is no. So, it matters. Order matters. Which order I put these in. So this is a locker permutation. So I have petitioned the administration to change the name from locker combinations to locker permutations, because really they have it all screwed up, and we would like to be correct. And so, here in the math department, we would like them to change that. Now, let's take a look at what the definition of combinations would be. You've seen a formula similar for permutations. Well, instead of NPR, it's NCR. Now, this represents the number of objects to choose from. And R represents the number of objects in a group. So we have the number of objects to choose from, and then the number of objects in a particular group. Now the definition for NCR looks like this. N factorial over N minus R factorial times R factorial. Now, that means that there's an extra term down here in the denominator, which is going to cause the whole thing to get smaller than the permutation formula. That makes sense. There are fewer groups than there are permutations. When you write it out for a situation where you have 6 objects and you're choosing a group of size 2, then that's 6 factorial. 6 minus 2 is 4 factorial. R would be 2 factorial. Now, I want you to take a look at that formula, because what you'll notice is that the number 4 and 2 add up to the number 6. No, that does not mean everything cancels out. You know what factorial means. You know that you need to write out all the factors and see what cancels out. Now, this particular formula right here would be a great way to solve a different question. Let's suppose there are 6 people in a room, and they all want to shake hands. How many different handshakes will occur? Well, this person can shake hands with 1, 2, 3, 4, 5 different people. This person over here already shook hands with the first person, so they shake hands with 1, 2, 3, 4 new people. This person is already shaking hands with these two, so they have 1, 2, 3 new hands to shake. This person has 1, 2 new hands to shake, and this person has a single hand that's new to them. This person right here has shaken hands with everybody, so they don't have any new ones to shake. So 5 plus 4 plus 3 plus 2 plus 1 is the same thing as 6 objects, and we're choosing a group of size 2. So, using our machine, six, math, PRB, third one down on the list, NCR, 2. That's 15, which happens to be the same thing as 5 plus 4 plus 3 plus 2 plus 1. 15. We're going to use the combination formula a lot. So let's suppose you expanded this idea to n people. That would be n factorial over n minus 2 factorial times 2 factorial. Well, we can see what cancels out here. N factorial is really n times n minus 1 times n minus 2 times n minus 3, blah, 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 blah. We've got n minus 2 times n minus 3 times blah, 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 all in the bottom. Don't forget your 2 factorial, right? That's a 2 times a 1, which is really just 2. Everything cancels out, so here we go. Right there is what we're left with. So we can even boil it down to figuring out a formula that would work. Now, if we look at another example, suppose there are 5 finalists, all receiving a $5,000 scholarship. Does the order matter? So if you and 4 other people you knew were all in some contest to get a $5,000 scholarship, maybe we wrote an essay or something, and would you care what place you came in? Probably not, if everybody was going to get a $5,000 scholarship. So does order matter? No. So this would be a combination situation. Well, if the 5 finalists receive $10,000, $5,000, $2,000, $1,000, and $500 scholarships, does the order matter now? Well, sure, it matters to you whether you get first, second, third, fourth, or fifth, because the prices are different, or the scholarship amounts are different. So this would be a permutation situation, because how you arrange the objects makes a big difference. Example 3 talks about going to a Chinese restaurant. There are 48 dishes on the menu, and you and 5 other friends are going to pick 6 different meals and then kind of share them to try different foods that you maybe not have tried before. So how many different dishes could you select? We don't care what order we order them in. We don't care what order we get them in. We don't care what order we eat them in. So order does not matter. That is a combination situation and is very easy to work with. 48. Oh. 48. Math. PRB. 6. Looks like 12,271,512. Now, in a different example, example 4, there are 60 members on the football team. What's the probability of selecting the star QB and running back? If you're selecting 7 people for random drug testing. Well, we can figure out that if there are 60 people that are being chosen from, how many groups of 7 can we get? So this is the total number of groups of 7 that could be chosen. We're going to split this up into 2 different groups. One group is going to have the running back and the quarterback. And out of that group of 2, we're going to select both of them. So out of that group of 2, we're going to select a group of 2. Now, if you do the math there, there's only one group there, so that's a real no-brainer. The number there is 1. But we're going to multiply that times another number. Of the others from the rest of the team, there are 58 remaining players. We want a group of 5 of them. Right? Because 5 plus the quarterback and the running back makes 7. So, in other words, it looks kind of like in the numerator here that we have selected the quarterback and running back and then selected a smaller group from the rest. Well, that's exactly what we've done, because probability is always about the chance of something happening, or the number of ways that it can happen divided by the total number of possible ways. We learned about that in Chapter 7. So let's see here. 58, Math, PRB, NCR, 5. So we have 4,582,116 divided by 60, Math, PRB, too far, NCR, 7. 386,206,920. So let's take the 458,2116 and divide by the answer. Looks like there is a 1.2% chance. 1.2% chance. 0.012, which is equal to 1.2%. Okay? How many 5-card hands can be drawn from a standard card deck? How many 5-card hands? Well, there's 4 suits, and they each have 13 cards, so that makes 52 total cards in a standard playing deck. So if you have 52 cards and you're choosing a group of 5, we can figure out, using our 52 NCR 5, that would be 2,598,960 different groups. What's the probability of drawing 4 hearts and 1 diamond? Well, okay, so we've got one group, there's 13 hearts, and we're choosing 4 of those. We also have 13 diamonds, and we're choosing 1 of those. And then, of course, we have the 52 choose 5 in the denominator. So 13 NCR4 is 715. And 13 NCR1, of course that's 13. Divided by that number we before. So if I multiply those two in the top and divide by the denominator, 2, 5, 9, 8, 9, 6, 0, we end up with 0.0036, or a 0.36% chance of getting 4 hearts and 1 diamond. Not that it's not possible, just fairly small. See you in class.